Good afternoon viewers, myself Rajinder Kumar. I am working as a senior lecturer in electrical engineering department at Government Polytechnic College, Amritsar. So, in this lecture we shall discuss about the transmission system. So, let us start with this topic. So, viewers, as we know, after electricity is produced at power plants, it has to get to the customers that use the electricity. So, our cities, towns, states, and you can say the entire country are crisscrossed with power lines. Those power lines carry the electricity, and those lines are called the transmission lines. So, viewers, transmission lines are those lines travel through tower to tower, means steel tower to steel tower. Those lines are called the transmission lines. So, viewers, as we know, the generating powerhouse generators, when they spin, they produce electricity with a voltage of about 11,000 volts, or we can say 11 kV. So, viewers, we are already well familiar with the term generators. So, generator की है. So, generator एक machine है in which there is a conversion of one form of energy to another form. So, generators, they convert mechanical energy into electrical energy, and the weight of that type of electrical energy is 11 kV, or we can say 11,000 volts. So, viewers, this picture shows how electricity is produced. So, there is a generator. So, this is the generator. So, this is the penstock, and this is the reservoir. So, water is stored at this place. So, water that moves through penstock, and penstock that is connected with the blades of a turbine. So, blades are attached to the shaft of this turbine, shaft of the generator. So, this way mechanical energy is converted into electrical energy. So, there are so many means of power generation. So, this picture shows generation caused by the hydraulic dams. In India, all the generators installed at various types of powerhouse generate only 11 kV. But there are some countries where the generation is more than 11,000 11 kV, like 33 kV, 11.5, etc. But in India, generation is only up to 11 kV. Various means are there. to generate electricity. These methods are hydraulic powerhouse, as we have shown in earlier slide. Second one is thermal powerhouses. Third is nuclear powerhouses. So, viewers, in first case we make use of water as a production of electrical power. In second means we make use of steam for the production of electricity, and in third, which is more important also, nuclear powerhouses, we make use of nuclear energy. So, this is the picture showing the transmission system, our transmission system, how electricity is produced and how electricity reaches to our houses. So, these are the transmission lines. These transmission lines travel from tower to tower, tower to tower. So, in India, first electricity is generated at powerhouses, then 11 kV is stepped up to the 400 kV or 800 kV. Then this 400 kV is transferred to, or you can say stepped down to 220 kV or 132 kV lines. So, next it is stepped down to 66 kV or 33 kV at the substation installed at various places. So, then this type of electrical energy is stepped down to 11 kV oblique 415 volts by using a transformer that is also called distribution transformer. So, this transformer will be discussed also in this lecture. So, in previous picture we have shown the full scheme of transmission system, including primary transmission and secondary transmission. From higher voltage to lower voltage for the consumer. So, viewers, for domestic and commercially use in steps, first extra high voltage more than 400 or 400 kV, high voltage somewhat lower voltage, that is 220 and 132 kV. Next one is 66 kV and 33 kV. Fourth one is 11 kV oblique 415 volts. Fifth is domestic and commercially use. So, in this diagram all the steps has been shown. So, the electricity first goes to a transformer at the power plant that boosts the voltage up to 400, or you can say 400 kV volts, means 4 lakh volts. When electricity travels long distances, it is better to have it at higher voltages. Another way of saying this is that electricity can be transferred more efficiently at higher voltages. So viewers, question arise ਹੁੰਦਾ है कि why we step up the voltage up to this high extent, means 4 lakh volts or 400 kV volts. So reason is there कि electricity can be transferred more efficiently at higher voltages. So that is why we step up the voltage up to high extent. So the long thick cables of transmission lines are made of copper or aluminum because they have a low resistance. We know copper and aluminums are best suitable conductor of electricity. So that is why these type of conductors are used in transmission line as a conductor to conduct the electricity. So we know that the higher the resistance of a wire, more warmer it gets. So some of the electrical energy is lost because it is changed into heat energy. So high voltage transmission lines carry electricity long distances to a substation. So viewers, we know ਸਾਨੂੰ ਪਤਾ ਹੈ ਕਿ ਜੇਕਰ ਰੇਸਿਸਟੈਂਸ ਕਿਸੇ ਵੀ ਮਟੀਰੀਅਲ ਦੀ, ਕਿਸੇ ਵੀ ਕੰਡਕਟਿੰਗ ਮਟੀਰੀਅਲ ਦੀ ਜ਼ਿਆਦਾ ਹੋਏਗੀ ਤੇ ਉਹ ਮਟੀਰੀਅਲ ਹੈ ਜਦੋਂ ਕਰੰਟ ਪਾਸ ਕਰਾਂਗੇ ਤਾਂ ਉਹ ਜ਼ਿਆਦਾ ਹੀਟ ਅਪ ਹੋਏਗਾ. So that is why we make use of aluminum and copper as a conducting material, because copper and aluminums are good conductor of electricity because of low resistance, and और ਉਹ ਜਿਹੜੇ ਮਟੀਰੀਅਲਸ ਨੇ ਉਹ ਗਰਮ ਵੀ ਘੱਟ ਹੋਣਗੇ ਕਿਉਂਕਿ ਉਹਨਾਂ ਦੀ ਰੈਸਿਸਟੈਂਸ ਘੱਟ ਹੈ. ਸੋ ਦੈਟ ਇਜ਼ ਵਾਈ for electricity we make use of these types of conductors. So electrical power is generated at different generating stations. These generating stations are not necessarily situated at the load center. During construction of generating station, number of factors to be considered from economical point of view. So these all factors may not be easily available at load centers. Hence generating station are not normally situated for away from load center. So viewers, एक बहुत ही क्वेश्चन बड़ा मजाके जिहा है कि ਜਨਰੇਟਿੰਗ ਸਟੇਸ਼ਨ ਜਿਹੜੇ ਹੈਗੇ ਆ, ਮੰਨ ਲਓ ਕਿ ਕੋਲਾ ਜਿਹੜਾ ਹੈਗਾ ਥਰਮਲ ਪਾਵਰ ਹਾਊਸ ਲਈ ਆਪਾਂ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ. ਸੋ ਕੋਇਲਾ ਜਿਹੜਾ ਹੈਗਾ ਬਿਹਾਰ ਤੋਂ ਟਰਾਂਸਫਰ ਹੋ ਕੇ ਇੱਥੇ ਆਉਂਦਾ ਹੈ, ਇੰਨਾ ਟਰਾਂਸਪੋਰਟੇਸ਼ਨ ਦਾ ਖਰਚ ਹੁੰਦਾ ਹੈ. ਸੋ ਕੁਐਸਚਨ ਜਿਹੜਾ ਹੈਗਾ ਰਾਈਜ਼ ਹੁੰਦਾ ਆ ਕਿਉਂਕਿ ਕਿਉਂ ਨਾ ਆਪਾਂ ਜਿਹੜਾ ਹੈਗਾ ਆ ਜਨਰੇਟਿੰਗ ਪਾਵਰ ਸਟੇਸ਼ਨ ਹੈਗਾ ਆ ਉਹ ਬਿਹਾਰ ਵਿੱਚ ਹੀ ਖੋਲ੍ਹੀਏ ਜਿੱਥੇ ਕਿ ਕੋਲਾ ਜਿਹੜਾ ਹੈਗਾ ਮਿਲਦਾ. ਬਟ ਵਿਊਜ਼ ਇਸ ਤਰ੍ਹਾਂ ਨਹੀਂ ਹੈ, ਇਸ ਤਰ੍ਹਾਂ ਨਹੀਂ ਹੁੰਦਾ ਕਿਉਂਕਿ ਇੱਕ ਥਰਮਲ ਪਾਵਰ ਹਾਊਸ ਜਿਹੜਾ ਹੈਗਾ ਆ ਉਸ ਨੂੰ ਰਨ ਕਰਨ ਦੇ ਲਈ ਔਰ ਉਸ ਨੂੰ ਜਿਹੜਾ ਹੈਗਾ ਆ ਨਵੇਂ ਥਾਂ ਇੰਸਟਾਲ ਕਰਨ ਦੇ ਲਈ ਬਣਾਉਣ ਦੇ ਲਈ ਕਈ ਫੈਕਟਰਸ ਦੇਖਣੇ ਪੈਂਦੇ ਆ ਕਿ ਉਸ ਥਾਂ 'ਤੇ ਉਹ ਜਿਹੜਾ ਹੈਗਾ ਆ ਸੂਟੇਬਲ ਪਲੇਸ ਹੈ ਜਾਂ ਨਹੀਂ। ਸੋ ਇਸੇ ਕਰਕੇ ਲੋਡ ਸੈਂਟਰ ਜਿਹੜਾ ਹੈਗਾ ਆ ਕਿਤੇ ਹੋਰ ਹੁੰਦਾ ਆ, ਫਿਊਲ ਕਿਤੇ ਹੋਰ ਹੁੰਦਾ ਆ ਜਿੱਥੇ ਸਾਨੂੰ ਮਿਲਦਾ ਆ, ਬਟ ਜਿਹੜਾ ਹੈਗਾ ਆ ਇਹ ਸਾਰੇ ਫੈਕਟਰ ਜਿਹੜੇ ਹੈਗੇ ਆ ਕੰਬਾਈਨ ਨਹੀਂ ਹੋ ਸਕਦੇ। ਸੋ fundamentally there are two systems by which electrical energy can be transmitted. First, high voltage DC electrical transmission system. Second, high voltage AC electrical transmission system. So there are some advantages in using DC transmission system, but in India we are using high voltage AC electrical transmission system. Because maintenance of AC substation is quite easy and economical compared to DC system. The transforming in AC substation is much easier than motor generator sets in DC system. Third one is AC substation system is simple to adopt as compared to DC system. So viewers, why we prefer AC transmission? हालांकि साढ़े कोल DC transmission भी है, but we prefer AC transmission because we are some advantages for transmission of AC. First one is we have discussed कि maintenance ਜਿਹੜੀ ਹੈ ਉਹ AC substation ਹੈ ਉਹਨਾਂ ਦੀ easy ਹੈ as compared to DC system. Second ਜਿਹੜਾ ਹੈ ਉਹ ਇਹ ਹੈ ਕਿ DC motor generator set ਹੈ ਜਿਹੜਾ ਕਨਵਰਸ਼ਨ ਵਾਸਤੇ ਆਪਾਂ ਯੂਜ਼ ਕਰਾਂਗੇ ਉਹ ਜਿਹੜਾ ਹੈਗਾ ਇਕਨੋਮਿਕਲ ਨਹੀਂ ਹੈ। ਸੋ ਇਸ ਕਰਕੇ ਜਿਹੜਾ ਹੈਗਾ ਆਪਾਂ AC ਸਬਸਟੇਸ਼ਨ ਸਿਸਟਮ ਨੂੰ ਅਡਾਪਟ ਕਰਦੇ ਹਾਂ। Even having these advantages in DC system, generally electrical energy is transmitted by three-phase AC transmission system. The alternating voltage can easily be stepped up by using a step up transformer which is called as power transformer 2, and step down by using power transformer and distribution transformer both, which is not possible in DC transmission system. So viewers, we know कि DC वोल्टेज ਨੂੰ ਆਪਾਂ ਸਟੈਪ ਅਪ ਜਾਂ ਸਟੈਪ ਡਾਊਨ ਨਹੀਂ ਕਰ ਸਕਦੇ। ਸੋ DC ਨੂੰ ਆਪਾਂ ਮੋਰ ਦੈਨ ਵਨ ਫੇਜ਼ ਆਪਾਂ ਚੇਂਜ ਨਹੀਂ ਕਰ ਸਕਦੇ, ਬਟ AC ਹੈ, AC ਜਿਹੜੀ ਹੈ that can be stepped up and stepped down with the help of various types of transformer very easily. So that is why we adopt AC transmission system. AC transmission system is more likely to be affected by corona than DC system. Construction of AC electrical power transmission network is more completed than DC system. Next one is proper synchronizing is required before interconnecting two or more transmission lines together. But in case of DC transmission system, synchronization can totally be omitted. Electricity is generated in power stations and from there it is transmitted across the country by power cables to towns and villages. As we know, all cables have resistance, and so as the electricity passes through them. It will lose energy as heat in the cable due to its resistance. So, that is why resistance say that must be very low, otherwise heat will be produced that will cause the efficiency of the transmission lines or conductors. So, the energy lost in a power cable that is carrying a current I and is of resistance R is given by this formula. So, as we know power loss due to heat that is given by square of current and resistance of the material used. So, ਜੇਕਰ resistance ज़्यादा होएगी तो पावर लॉस ਜਿਹੜੇ ਹੈਗੇ ਆ ਉਹ ज़्यादा ਹੋਣਗੇ। सो दैट इज़ वाई ਸਾਡੀ ਕੋਸ਼ਿਸ਼ ਹੁੰਦੀ ਹੈ ਕਿ ਆਪਾਂ ਉਸ ਤਰ੍ਹਾਂ ਦਾ ਕੰਡਕਟਿੰਗ ਮਟੀਰੀਅਲ ਯੂਜ਼ ਕਰੀਏ ਜਿਸ ਦੀ resistance ਘੱਟ ਹੋਏਗੀ। ਸੋ देयर आर सो मैनी टाइप्स ऑफ मटीਰੀयल्स ਜਿਨ੍ਹਾਂ ਦੀ resistance ਘੱਟ ਹੁੰਦੀ ਹੈ ਔਰ ਆਪਾਂ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ ਟਰਾਂਸਮਿਸ਼ਨ ਲਾਈਨ ਦੇ ਲਈ। As we can see, the power loss depends on the resistance of the cable, and so to reduce this power loss the resistance of the cable must be as small as possible. So, the resistance of a given length of cable can be reduced by ਆਪਾਂ resistance ਨੂੰ ਕਿਸ ਤਰ੍ਹਾਂ reduce ਕਰਾਂਗੇ by using thicker cables, but this will make them too heavy. Second is using material which is a better electrical conductor such as silver, but silver is too expensive ਜਿਸ ਨੂੰ ਆਪਾਂ as a transmission of electrical energy use नहीं कर सकते। Next is cooling the cables with a jacket of liquid hydrogen। ਇਹ ਵੀ ਬੜੀ ਐਕਸਪੈਂਸਿਵ ਹੈ, ਬਟ ਇਹ ਜਿਹੜੇ ਹੈਗੇ ਆ ਮੈਥਡਸ ਨੇ ਜਿਨ੍ਹਾਂ ਕਰਕੇ ਆਪਾਂ ਐਫੀਸ਼ੀਐਂਸੀ ਨੂੰ ਇਨਕਰੀਜ਼ ਕਰ ਸਕਦੇ ਹਾਂ ਫॉर the transmission of electricity. So, changing the resistance is not a practical idea, but the current passing through the cable can be altered using a transformer. So, viewers, to keep the power loss as small as possible, the transmitted voltage is very low. Electricity generated in a power station at 11 kV is stepped up to 220 kV or 400 kV for transmission across large distances near towns, villages and industrial sites. There are transformers that step down the voltage ready for use. So, a transmission line has the following accessories: lattice steel tower, cross arms, dampers. So, dampers, these are the dampers. I will show you in the next slide. Spacers, conductors, insulators, ground wire, horn gap arresters, bird guard, danger plate, which is not shown in this diagram, but there is a danger plate also. So, in this case some accessories are clearly visible. So, these are the dampers to damp the vibration occur due to wind. These are the conductors for transmission of electrical energy. So these are the insulators. So these are the spacers clearly visible, and above all this one is the earth wire. So these are the cross arms viewers, जिस तरह बाਹਾਂ ਆਪਾਂ ਕਹਿੰਦੇ ਹਾਂ. So these are the arms of a tower. So in this diagram dampers are shown. So viewers, these are the dampers. So ਇਹਨਾਂ ਦੀ ਸ਼ੇਪ ਜਿਹੜੀ ਹੈ ਡੰਬਵੈਲ ਟਾਈਪ ਹੁੰਦੀ ਹੈ, ਜਿਸ ਤਰ੍ਹਾਂ ਕਿ ਆਪਾਂ ਡੰਬਲ ਜਿਹੜੇ ਹੈਗੇ ਆ ਆਪਾਂ ਫਿਜ਼ੀਕਲ ਪ੍ਰੈਕਟਿਸ ਵਾਸਤੇ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ. ਸੋ ਬਿਲਕੁਲ ਇਹਨਾਂ ਦੀ ਜਿਹੜੀ ਹੈਗੀ ਸ਼ੇਪ ਡੰਬਵੈਲ ਟਾਈਪ ਹੀ ਹੈ. ਸੋ ਇਸ ਨੂੰ ਆਪਾਂ ਡੈਂਪਰਸ ਕਹਿੰਦੇ ਹਾਂ. ਸੋ ਇਹਨਾਂ ਦਾ ਜਿਹੜਾ ਹੈ ਕੰਮ ਹੈ ਉਹ ਵਾਈਬ੍ਰੇਸ਼ਨ ਨੂੰ ਜਿਹੜਾ ਹੈਗਾ ਡਿਊ ਟੂ ਵਿੰਡ ਜਿਹੜੀ ਹੈਗੀ ਆ ਇਸ ਨੂੰ ਉਹ ख़त्म ਕਰਦੇ ਨੇ. ਸੋ ਲਗਭਗ ਜਿਹੜਾ ਹੈਗਾ ਆ ਇਹ ਜਿਹੜਾ ਹੈਗਾ ਆ ਇਹ ਟਾਵਰ ਤੋਂ ਜਿਹੜਾ ਹੈਗਾ ਆ ਇਹਦੀ ਡਿਸਟੈਂਸ 1 ਮੀਟਰ ਦੇ ਆਸ-ਪਾਸ ਹੁੰਦੀ ਹੈ. ਸੋ ਇਸ ਨੂੰ ਆਪਾਂ ਜਿਹੜਾ ਹੈਗਾ ਆ ਡੈਂਪਰਸ ਨੂੰ ਇਸ ਤਰ੍ਹਾਂ ਜਿਹੜਾ ਹੈਗਾ ਆ ਨਾਲ ਜਿਹੜਾ ਹੈਗਾ ਇਸ ਨੂੰ ਇੰਸਟਾਲ ਕਰਦੇ ਹਾਂ. So transmission system requirements listed below are the typical points to be considered before starting or even operating an electrical power system. These factors can be best categorized into three main points: electrical design, mechanical design and structural design. So electrical design of AC system involves power flow requirements, system stability and dynamic performance, selection of voltage level, voltage and reactive power flow control, conductor section, losses, corona related performance due to radio, audible and television noise, electromagnetic field effects, insulation and over voltage design, switching arrangements, circuit breaker duties, protective relaying. Mechanical design involves sag and tension calculations, conductor composition, conductor spacing, types of insulators, selection of conductor hardware. Structural design involves the following points: selection of the type of structures to be used, mechanical loading calculation, foundations, guys and anchors, line location, equation of right of way profiling, locating structures, inductive coordination, seismic factors, types of aluminum conductors that are used by many transmission and distribution utility worldwide. AAC means all aluminum conductors. AAAC all aluminum alloy conductors. ACSR aluminum conductor steel reinforced. ACAR aluminum conductor alloy reinforced. ACSR, which consists of a central core of steel, stands surrounded by layers of aluminum stands, is now the types of configuration that are popularly used as conductor for transmission line. So viewers, ACSR ਕੰਡਕਟਰ ਨੂੰ ਆਪਾਂ ਜ਼ਿਆਦਾਤਰ ਇੰਡੀਆ ਵਿੱਚ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ ਫॉर ਦਾ ਟਰਾਂਸਮਿਸ਼ਨ ਆਫ ਇਲੈਕਟ੍ਰੀਕਲ ਐਨਰਜੀ. ਸੋ ACR ਕੀ ਹੈ ਕਿ conductors are further classified into many types and they are categorized according to the number of aluminum and steel stands present in the cable. This figure shows the different kinds of ACSR. So with ਇਹ ਇੱਕ ਜਿਹੜਾ ਹੈਗਾ ACSR ਕੰਡਕਟਰ ਹੈ. ਸੋ ਆਹ ਜਿਹੜਾ ਹੈਗਾ ਆ ਨੀਲਾ ਜਿਹਾ ਕੰਡਕਟਰ ਦਿਖਾ ਲਿਆ ਹੈ, ਇਹ ਜਿਹੜਾ ਹੈਗਾ ਆ ਸਟੀਲ ਦੀ ਵਾਇਰ ਹੈਗੀ ਆ. ਸੋ ਇੱਕ ਵੀ ਹੋ ਸਕਦੀਆਂ ਔਰ ਇੱਕ ਤੋਂ ਜ਼ਿਆਦਾ ਵੀ ਹੋ ਸਕਦੀਆਂ. ਆਹ ਆਲੇ ਦੁਆਲੇ ਜਿਹੜਾ ਹੈਗਾ ਆ ਇਹ ਸਰਾਊਂਡਡ ਹੈ, ਇਹ ਜਿਹੜੇ ਹੈਗੇ ਇਹ ਐਲੂਮੀਨੀਅਮ ਕੰਡਕਟਰ ਹੈ. ਸੋ ਦੈਟ ਇਜ਼ ਵਾਈ ਆਪਾਂ ਇਸ ਨੂੰ ਕਹਿੰਦੇ ਹਾਂ ਕਿ ਐਲੂਮੀਨੀਅਮ ਕੰਡਕਟਰ, ਸਟੀਲ, steel reinforced ਸੋ ਐਲੂਮੀਨੀਅਮ ਕੰਡਕਟਰ ACS ਕੰਡਕਟਰ ਹੈ ਵਿਊਜ਼। ਇਹ ਗੱਭੇ ਜਿਹੜੀ ਹੈਗੇ ਸਟੀਲ ਦੀਆਂ ਵਾਇਰਸ ਹੈਗੀਆਂ ਔਰ ਇਹ ਡਿਫਰੈਂਟ ਇਹਦੇ ਵਿੱਚ ਦੇਖ ਲਓ ਤੁਸੀਂ ਐਲੂਮੀਨੀਅਮ ਕੰਡਕਟਰ ਜਿਹੜੇ ਆਪਾਂ ਕਿੰਨੇ ਸ਼ੋ ਕੀਤੇ ਆ। ਸੋ ਐਲੂਮੀਨੀਅਮ ਵਾਇਰ ਦੀਆਂ ਸਟੈਂਡਸ ਔਰ ਐਲੂਮੀਨੀਅਮ ਕੰਡਕਟਰ ਦੋਨੇ ਹੀ ਜਿਹੜੇ ਹੈਗੇ ਆ ਉਹ ਆਪਾਂ ਵਧਾ ਘਟਾ ਸਕਦੇ ਹਾਂ। ਕਰੈਕਟਰਿਸਟਿਕਸ ਜਿਹੜੀਆਂ ਹੈਗੀਆਂ ਵਿਊਜ਼ ਉਹ ਕੀ ਹੋ ਸਕਦੀਆਂ ਨੇ ਕੰਡਕਟਿੰਗ ਮਟੀਰੀਅਲ ਦੀਆਂ? ਹਾਈ ਕੰਡਕਟਿਵਿਟੀ, B high tensile strength, C should not be brittle, low cost ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ, low specific